Okay, so today we're going to be doing question 232, implementing queues in stacks. So my last video, we were talking about using stacks for parentheses, right? In this instance, we're using stacks and queues. Um, so like I mentioned before, stacks is a type of data structure where you think of it as first in, last out. Queues are literally the exact opposite, right? Queues are first in, first out. So think of a stack like the block example, where when you stack blocks, you start with the first one, then you stack a block above it, and you want to grab the first block you ever placed. Well, it's all the way in the bottom, right? It's all the way in the end. So you need to remove the most recent blocks you placed to get back to that, right? And vice versa for queues. If you're waiting in line, right, the first person who is in line is going to be the first person to get out, right? So with this question, now knowing that, what this question is saying is it basically wants to allow you to create um, create like a class, right? Or you get a class and you have a bunch of functions with it, right? And you want to basically create a queue using stacks. So, you have all these methods, right? Like pop, peek, push, that are in queues. And in order to get that, we're going to be using the stack data structure to kind of create the result that you would get if you were to use queues. Um, so you're probably asking yourself, okay, how are you going to do that if they're literally the exact opposite? And to be honest with you, it's very simple, right? We're just going to create we're going to create another function to do that. So in order to create this function, we could just call it transfer, right? And then inside we put self. Now, why do we do self, right? You're taking a look and you see self here, self here, self here. So when you create inside a class, right, we have this init situation, which is sort of a constructor, which actually we're going to start off with this, right? We're going to do uh, self dot stack one, which is, think of stack one as a variable name, and self dot stack two. We just created two stacks, right? So this self is when we have multiple functions within the same class and we want to call those functions, we use this self argument, right? So, um, the x here is just something that will be passed on for push, right? Don't focus too much on the x. All these other selves are basically saying, okay, we are a function, right? We're a function all in the same class myQ, right? We're going to be calling these functions, so we need to make sure we have self. And because of that, because we have the self, the variables that we're creating have to have the self dot right before it. Nothing too crazy. It's just you use the self when you are using a function within the same class. So you have this transfer. The first thing we're going to do, if not stack 2, right? And we have to do self, because remember, that is the variable. If not self stack 2. So what this is saying, right, is, if I was to take this away, if not stack 2, right, this is saying if there are no values in stack 2, do the code underneath, which is important because we need to make sure stack 2 is empty. So what we're going to do is we're going to do stack 2, or no, we're going to do a first while loop. Well, self.stack1, right? So while I know it's confusing, so we're actually going to create comments. This is saying if stack 2 is empty, do this. And this is a while loop. While there are values in stack 1, do this, right? And then what we're going to do is stack 2, well, self dot stack 2 dot append self.stack1 dot pop, right? So what's happening here is if stack2 is empty, run all the code below. While there's values in stack1, we are adding values into our stack2, those values being the last value of stack1. So to visually kind of show it, right? The last values, let's say we have these two stacks, right? This will be stack 1, this will be stack 2, right? Stack 1 is 1, 2, 3, 4, right? Because stack 1 is literally the opposite, right? Think of stack 1 as literally a stack, and we're creating the queue, right? Stack 2 was the queue. Stack 2 is what queue should be looking like. So we are popping the values from stack 1, which pop removes the last value put in, right? And then we're adding it to stack 2. So look, the first iteration of this while loop removes 4. Let's remove it and add it to stack 2. The next iteration removes 3 and adds it to stack 2. The second iteration removes 2, add it to stack 2, and then you remove 1 and add it to stack 1. While there are values in stack 1, there are no more values in stack 1. So this loop ends, and you're left with stack 2 equals 4, 3, 2, 1, which is literally the opposite. So now as we have the reverse of what a stack is, which is literally what a queue is, just the reverse of it, right? We're able to use these functions to grab values from here, right? Basically giving you the right answer. So some of those would probably be pop and peek, right? So pop, right? The dot pop function removes the last value, right? So if we're given a stack, we need to reverse that and grab the last value. So let's take a look of how that function will work, right? So stack 1 initially looks like this, 1, 2, 3, 4. If we were to use the pop function, or the pop function / method on stack 1, you would get 4, right? This, though, is for stacks. We don't want a stack, we want a queue, right? So if we want a queue, then we would want to get 1, right? Because it's first in, first out, right? First in is 1. So when we pop it, the first out should be 1. So the way to do that is by reversing what we have. So next time when we remove, we're going to get 1, right? This is why we do the reverse. So initially when you do stacks, it's 1, 2, 3, 4. The dot pop removes the last iteration. 4 stacks, right? That's 4. Queue removes the first iteration when you use pop. But we can't do that. The only way we could do that is by reversing, which is why we created a whole other stack called stack2 for this exact moment. So we're going to first call the function, which is transfer, and we have to have the self, right? Self.transfer. This calls our function. Then we're going to return self.stack2.pop, right? So now we're calling stack2, which is this, right? And we're popping it, which is going to get you 1. And we're returning 1. So every time you use this now, it should give you 1, right? Now let's do that for peek, right? It's the same thing. Self dot, or well, not dot, you have to also add underscore transfer, right? Then we're going to want to return self dot stack 2 -1. So we're returning the last index of stack 2, which is 1, right? And and we want to be able to use this peek method in order to get that. So the reason why we do that is we call this function, right, the transfer, and we're returning, right, because we want to be able to use this for later on. So we return it, and we use self because of the arguments here, and we put -1 so we can mimic the behavior of peek. And then push and empty do not really require us to do anything. Push is just adding values into stack 1. So we would just do self, because remember we have to always do that. And this time we do stack 1. And then with that, we're going to do append x, right? Push is basically just adding values, right? So that's why we just use the append method, and we add whatever x is. And then empty is basically a method to check, is the given stack empty, right? So we just need to return a true or false. So we're going to return the length of self stack 1, right, equals 0, and the length of self dot stack 2 equals 0. So we're making sure that stack 1 and stack 2 are equal to 0. If they are, then that means that it is empty and it will return true, right? And with that being said, I think everything is done. Let's give it a run. And yes, so you do get the acceptance if I click submit. Beautiful, yeah. And you get the problem sorted out. So really the main takeaway from this problem is you're given these functions: pop, peek, empty, push, and init, right? The only thing you had to create yourself was this function, which is the transfer one. It can be any name, right? All you need to do is just do an if statement, a while statement, and to add those pop values into the stack, right? This allows you to basically bypass the rules that stack has, because, like I mentioned, stack is the opposite of queue. So this is basically just giving you the opposite of the stack that you have right now, which is stack 1. Stack 1 is the OG stack, which has everything that it needs, right? And the transfer basically just reverses that. So you're able to use that reverse to then create these other functions that you have over here.